Hi, I'm Matthew Adam, and I'm here to talk about a situation where an IoT device is required. Currently, there is a warehouse that has an automatic stock retrieval system with about 30 conveyors. The original design of the warehouse was to accept pallets of 1.2 tonne, but the warehouse has only been getting pallets of 800 kilos for the last few years. But the concern is now production's now going to bring in heavier pallets, which could cause issues to motors and gearboxes. They've raised concerns that maybe the gearboxes might um, vibrate themselves off the motors, and with the additional load from the pallets, uh, additional strains now putting onto these motors, which could overheat. Um, they would like to monitor these motors and gearboxes with a very cheap and solution to be able to focus on them, because if they do need to be replaced, they want to replace them. But if they can get away with not needing to replace, then they won't replace. So my design, I came up with a temperature sensor to see temperature on the motors. Originally, it was going to be a thermistor installed into the motor itself, but as additional work would require to install and undo all motors, um, it really was over required, where monitoring of the heat coming off the motors and seeing if there was a huge spike from when there was an 800 kilo pellet going over versus 1.2 ton pellet going over it will make a difference. So my original design was to have a thermistor in there, but we ended up changing it just to the normal temperature, and then we're going to use the accelerometer as and attach it to the gearbox to see if the vibrations of it. So my solution was to be able to monitor the devices and have a light system to put a warning, then a stop. So, all right. So here's the Arduino code on the side. We will reset the device now. Um, we will also have putty up, and we will clear and create a new session for putty as well. Putty will only work when the data is required, and it would be then sent to wherever it is. So it's currently connected. We will demonstrate the temperature one first. So this is now just currently rigged at a way to show that the device, when it increases, it will light up one light, and then when it gets to the maximum temp, it will shut down. So if we just get it up, as you can see, the putty's now sending messages. Now it's going up, and we've hit over the mark of 40 degrees Celsius, which then has indicated that the motor would be too hot, but the blue light would have been on before that, so the worker went out and checked it. Now, with the accelerometer, this is now going under where it needs to be. So, accelerometer, if we slightly move it with a bit of luck, it's now warning with the blue light that has just gone on there. And it's advised that the amount of G's that have came from the actual device. So if it kept on going at a very low rate, it will just keep firing off the gearbox information off to putty, which will then store into a database. But then if it got really bad, it will light up red. Maybe I can see that red, meaning that the device itself would then shut down and the operations would cease. This data would then be sent off to whichever database you need to send it into to be able to collect the data. As this is a monitoring device, there will be a shutdown valve connected to it, but depending on the information and data gathering of where you want to cut that off will also determine of how you go about that as well.